ladies and gentlemen. I'm John Belkowitz.
I'm Brooke.
Director of R&D and Intelligent Concrete. Sorry, it was a long night last night.
I'm Brooke. Lab Tech.
So we're going to talk about a new project that we've got going on here. It was based off of a question that we had from the glow-in-the-dark concrete countertop. And Brooke has been our technician now for 3 months?
No.
How long?
About a month and a half.
Get out of Dodge.
Yeah.
Time flies when you're having
Yeah, I think so.
Okay.
Not that fast though.
So Brooke is still in our training process and going to start this whole training program on grouts.
Mm-hmm.
And what we're going to be doing simultaneously is a study on segregation control for grouts using high-range water reducers and changing water cementitious ratio. So I asked Brooke to be part of this because she had no clue as to what. Isn't that the truth?
That's true.
That's true.
That's true.
So, Brooke, we're going to dive into it, and I want you to ask the same questions
Okay.
that you were just asking.
Okay.
So, this study is on segregation control or segregation destabilization. Is, I guess, a shitty way of saying it, but another way of saying it. Do you get that?
Yes, I do now.
Okay.
I was asking, what exactly does that mean? And the answer is
So, what's the simple answer of it?
when the water pulls away from the concrete.
So, close.
Or cement.
So when the paste pulls away from the aggregate, that the paste is so fluid that it just drops out of solution, or when you do your spread, you'll see this nice halo effect.
Mm-hmm.
So that's when paste pulls away
Different than bleed water?
from ag. Absolutely.
Okay.
That is still a response from the force of gravity, but now it's everything heavier in the concrete is segregating down,
Okay.
and excess water is bleeding to the surface.
Sure.
That's actually a definition from ACI CT 18, concrete terminology. I had to look it up for one of our committees. There was a big fight going on, and it was all based on that definition. It was pretty freaking awesome. So the definition is paste pulls away from aggregate. And why do we care about that? Is because, the question was, when does segregation happen? And it's not a singular, mix. It's based on water cementitious ratio and your dosage of high-range water reducer. And that's what we're going to do. So the next thing is we're going to make this really, really simple for this study, right?
Mm-hmm.
So just going down the list.
Yeah.
We're going to do a Portland cement only mix. There's nothing wrong with using fly ash or supplementary cementitious materials, but we don't want to confuse this. We want to really do only we're doing 2 parameter changes, and that's enough. We're only going to be looking at fresh properties and limiting to it. We're going to come up with a pretty graph like this, but we're not going to be doing strengths on this specifically. We're going to be taking some mixes into that segregation zone.
Mm-hmm.
So we're just going to disregard strengths for this project and this project only. Any questions about that?
No.
Okay. So 4 mixes for every 1 water cement, or 4 mixes plus a reference on each one of those mixes with changing dosages of the high-range water reducer. So we're going to keep 2 things constant: the cement and the sand. We're going to be using ASTMC 1260, 1567, and then what we're going to change here is the water cementitious ratio from 0.3, 0.4, 0.5, 0.6. With in your current training, what do you think is going to happen as we increase the water cementitious ratio?
The slump is going to grow larger, the
Yeah.
spread.
Right. Awesome. Good job. Good job. So, based on that, we're going to have 1 reference with no high range, and then 3 increasing dosages of our high range water reducer. And right now we're using, I believe it's, well, let's leave that to the, when we do it, but we're doing 5, 10, and 15 fluid ounces per hundredweight. So it's probably somewhere around 1 milliliter, 1.5 milliliter, and 2 milliliters, or something to that effect. But we'll make that decision as we get closer when we look at our raw materials. So no F prime to C, so no strength, and we're not doing calorimetry curves or semi-adiabatic temperature curves. So that's cool, And the purpose of this. So what we want to do is generate this value that we're making up, and that's the sensitivity to segregation.
Mm-hmm.
Now we talked about this, and what I had said is that as we add more water and increase our high-range water reducer, we're going to see a higher sensitivity to segregation. And as our water cementitious ratio goes up, we should see that sensitivity segregation either should have a higher or lower value. Now, the question should be, what is the definition of sensitivity to segregation? And it's that experimental slump versus the reference slump. Does that make sense?
Yes, but how is that going to give us? Are we looking for the actual spread number?
Yeah.
Just okay.
Yeah, and we're going to compare it to the
The
reference
okay.
at that water cementitious ratio, and then graphically show what that comparison is.
Okay.
Now, I don't know, this might not work. You know, it looks like it should, but graphically we'll have to see it.
Yeah.
Sorry, go ahead.
I was just going to say, so that number, will it really give us a moment when the segregation occurs? Like it's...
Let's say this is our slump board, and we start out, this is the bottom of our slump cone, and we yank the slump cone out, you know, in our 3 to 7 seconds, we're going to have this spread, you know, that we measure at 90-degree angles. So what ends up happening is, sorry, let me just get another marker. Instead of spreading out, when we increase both our water cementitious ratio and our high range, we end up getting this higher spread. So the grout kind of out. I don't know. That just totally describes it. And what ends up happening is, let me see. We'll
Go
do
green.
Go green. I'm going green,
Use
folks.
green, yeah.
What ends up happening is you end up getting this separation of paste. So Brooke's question was, is this going to give us an instantaneous measurement of that segregation? It's not going to. It's not going to give us a measure of the shearing action that is needed or the energy that is lost. Or what it's going to give us is a measure of the impact of that ability for that or inability of that material to stay together due to the force of gravity. Because basically what we're trying to do here is create a self-consolidating grout, a grout that consolidates under its own weight due to the force of gravity. And we're doing that by increasing water cementitious as well as the high range, and that's the thing that we're focusing on, that combination. But what we could do with that is get to a certain point when our paste exceeds our granular skeleton, that there's too much paste for the surface area, and then ultimately the paste just destabilizes. And what we want to do is compare, again, the impact, that's the reference, right? So the reference, let's call it reference S, and then this average over here, and again these are averages, so I just want to push that up, is going to be your experimental spread. And comparing those two will have us, or give us the ability to understand what that change in water cementitious ratio and high range water reducer does to that design versus actual.
Right.
So again, it's the impact of, to answer your question, it's the impact of, not the actual segregation mechanism. Like, it's not the rheology or the fixotropic nature of it, which are really great words.
Yeah.
And we should do that. You just have to ask Whitney to buy a rheometer. I already picked one out. They're awesome.
Yeah.
So, yeah. So, Brooke has got a new project she'll bring to resources. We'll see how that goes.
Yeah. No.
No?
No.
So anyway, thanks for joining us today. Just wanted to go over this project. What we'll do is we'll dive into it with the mixes. We'll show you the data set, and I think we're even publishing a paper on this too. So let us know if you got any concrete questions, concrete concerns. Don't forget to like and subscribe. Ding that bell for notifications. Go Concrete!
Beat asphalt.